So I'm going to present the work that we did at Nomadic Labs to integrate Sapling in Tezos. So this is a presentation that I've given a couple of times already, and in Berlin, actually. So I'm going to try to cover, I think we already talked a lot about the privacy aspect. I'm trying to give it a little different twists today, and I'll try to speak more about the compliance side. So a little bit about me. I'm a developer at Nomadic Labs, which is a company in Paris that is funded by the Tezos Foundation, and whose main goal, its main focus, its only focus actually, is to work on Tezos. We are more than 30, I think we're approaching 40 OCaml developers. Most of us have a PhD in computer science and a background in academia. Mostly, I would say, from verification and programming languages, but not only that. What we do is, so there is a consensus team that's been working and designing ME since the beginning, and what became ME Plus and Plus, etc. They keep refining the current consensus algorithm that we have, and are exploring the various BFT algorithms that are popular these days. We have a lot of developers working on the Michelson smart contract language. We have, so there is also maybe the most the product, let's say, of Nomadic Labs that you've been most in contact with is the Tezos node, and the part that does the sort of the lower level bits, that is the storage and the networking. That's the stuff that we've been maintaining. And then we were the authors of the first protocols, and we're very happy to share this work now with others. Cryptium Labs for the past 2 protocols now, and we're working on 007 together. But there were also many other companies and individuals in the ecosystem that are contributing. So we're very happy to see the ecosystem decentralized a bit more. We have a small mobile team that does the Cortez wallet. And one focus that was there since the beginning, but is finally bearing some fruits now, is the formal methods. So we try to sprinkle all the other subjects with a little bit of formal methods. That is something that we're very fond of. All right, so there is a new, let's say, focus at Nomadic Labs. That is the privacy team. That is an effort that I started together with Marc Benardeau, that is a cryptographer that joined Nomadic Labs last year, and we're growing the team. So we have Danny that joined a few months ago, and we're trying to hire a new cryptography engineer. So let's see what exactly. So what was our focus on the past year? Was adding privacy-preserving transactions in Tezos, and we did this by integrating the Sapling protocol. So what, to maybe explain a bit better what this means. The Sapling protocol is a protocol that was designed and implemented by the Electronic Coin company. That is the main development company behind the Zcash project. They implemented the protocol in a very nice Rust library. So what we did was integrate this Rust library in our OCaml code base. And then we added a new opcode to the Michelson language to be able to use the Sapling protocol. This seems easy, but it was actually a lot of work to make it work efficiently in the protocol. The reason being that the Sapling storage can get very large, potentially can be very large, so you need to do some optimization and you need to be careful. It looks very similar to what big maps are doing, for example, if you know a little bit on Michelson. I'm going to describe it better later in more details, but that's the gist of it. So let me step back a little bit, and I'd like to talk about the motivation behind this work. So usually when I used to give this presentation, there was I used to go on and on about why financial privacy is important, especially for individuals, etc. So I'm going to skip this this time because I think the Zcash people already did a great job of motivating, designing, implementing, explaining, evangelizing, etc. of why financial privacy is important, especially for individuals. I would advise to go look at Ian Meyer's Satoshi Has No Clothes video. That makes you understand how bad is the situation with the more established cryptocurrencies. Any talk from Zuko would be very good, and they're very accessible. And have a look at on their blog. It's all very good material, and that's it. So I'm going to just keep going. The only thing that I would like to add about privacy for individuals is the GDPR. Just a quick rundown of GDPR. So it's the General Data Protection Regulation that is enforced in Europe. And it's I think it's a very nice effort that one kind of pioneered by the European Union, in the sense that has inspired many similar efforts in other countries. And it's very broad, and sometimes it's scary for people because of that. I think it's important for everybody that is building an application today that's going to collect some data to be at least familiar with some of the words that I put in the slide. So you should know that what could be considered personally identifiable information. You should know that even if you're using a pseudonym, it is still considered personal identifiable information. So, for example, in a cryptocurrency or in a blockchain, your TZ address, it's still considered personal identifiable information. Just because it starts with the TZ and there's a bunch of numbers and letters, it doesn't mean that I cannot link that to a person as much as a name or a surname could do. I think it's important to understand, if you're building an application, it's important to understand if you're a data controller or a processor, and it's tricky and complicated, but you should try to figure that out. And you should just be familiar with what is the right erasure and modification that your user might ask for. And finally, it's important to understand that data has to be minimized. So if you don't, so there should be a purpose to why you're collecting some data, and it should be limited as much as possible to that purpose. That's the general advice that I would give to somebody that is designing an application. And this is even more importantly for a blockchain, because there are potentially a lot of data that is going to be public and is going to stay there for a long time. I think, and this is just my opinion, so take it with a pinch of salt, I think Sapling goes in the very helps a lot with GDPR. I might go as far as saying that a Sapling-based application might comply with the GDPR. The reason I say this is because Sapling provides a form of anonymity, and anonymity is explicitly stated as a very desirable property for an application. So if you're again, I'm not an expert on GDPR, but I think if you can prove that your data is anonymous, then you fall outside the scope of GDPR. And another important aspect is that the data that is stored in the blockchain it's encrypted. And this is, again, encryption is one of the tools that the law tries to suggest. So it's not a very technical text, because anyway the technical part moves fast. So they try to make a law that's going to last a little bit, and it's try to give you the principles. But encryption is mentioned, so I think we're in good shape. Once again, it really depends a lot on what kind of application you're doing, and it depends a lot on the technical details. So the devil is always in the details. So it's really hard to define exactly what we mean by anonymity. And so if we're scientists, we're going to start talking about giving formal definitions with probabilities, etc. In a text of law, usually they don't do that. So maybe they will not consider the same thing that we do, anonymity. Encryption, again, is a very vague term. There are many ways to do encryption. Not all of them, they will stand the test of time. So just because you encrypted something with a weak encryption scheme now, it doesn't mean that it's going to be okay from the point of view of a data protection agency. So you still need to ask. So I think the best thing to do is get familiar with all these concepts, ask yourself a bunch of questions about your application you're trying to build, and then ask your data protection agency. There is one in every European country, so try to have a dialogue, try to ask, don't be afraid. They're not there to stop innovation, they're there to make sure that things go in the right way. I would say the last thing that you want to do is to launch your great product and then be stopped or fined because you did a stupid mistake that maybe you could have avoided at the design phase. So try to build a dialogue and be open, ask questions. They're usually very nice people that are trying to save the same problem as we are. So this is a bit my advice. So, okay. So anyway, if your users are not individuals, but for example, your application is for business to business application, then in that case, you fall outside the scope of GDPR. You might say, oh, okay, I don't care then. Still, it's very obvious that even a business wants, there is a big desire for privacy. You don't want your competitor to know who are your clients, who are your suppliers, where, how, and how much money you spend, etc. This is just I think it's very intuitive for everybody. And anyway, there are laws protecting also the business-to-business relationships. For example, there are laws protecting the market integrity. So it's not, I think so. I'm not an expert on this, but I think more or less one example for market integrity is if you see a very big player buying or selling a token, for example, this might influence a lot of other people, and this is considered not good for marketing. It's not a good property of a system if somebody can influence the system this much. For traditional financial services like banks, exchanges, standards, like classical, let's say, asset managers and insurances, these are all in these fields. People are very interested in blockchain, so we get questions all the time, but they're highly regulated, and for good reasons, for very good reasons. I'm not arguing against this, but the point is, for these people, many of the things that we give for granted, like just use a smart contract is going to be fine, just do a DApp, and for them is like absolutely out of the question. Like they're even if they want it, they really have strict regulations that most of the time they make a lot of sense. Sometimes they are a bit weird, I must admit, but in general they make a lot of sense, and they just can't. So they just cannot use the technologies that we are trying to build. So this is the motivation. So why I think that Tezos is going to be a very good platform for these people to look at in the next year. Is having a clear, so independently of what kind of governance, but having a clear definition of governance is very important. You want to know who's steering the ship, even if it's a decentralized system that tries to be fair. So the most important thing is to know. Then the way we do implement the governance is another topic. Already knowing is very good. The Michelson smart contract language makes a world of difference, and I'm going to say in the next slide why. And Sapling finally covers that big blind spot that was the privacy and data protection. So why Michelson? So Michelson was designed from the ground up with formal verification in mind. And it finally, there are other cases, but I would say that is a very prominent case of having finally a practical field where we can really formally verify critical code. If you've ever heard formal methods, usually there are two. Well, I would say there are three kinds of people. You never heard of it, you don't care. Okay, most people. You've heard of it, you've never worked on formal methods, and you will be a huge fan. You will, oh, that's great, it's amazing. Finally having mathematical proof that the system has a good property, that's exactly what I want. Should formally verify everything. And then there are the third category of people, that the people that have done some formal methods, and they're like, oh no, formal methods, not again. Like, they're great, don't get me wrong, but it's so hard. It's so they're expensive, it takes a lot of time, you need to really understand the problem. I mean, it's just tiring, and if you try to talk to a business person, it will be like, it's too expensive. We don't have the money. He's gonna delay the product by 10 years, so it's not absolutely out of the question. So here we finally are in a place where, I would argue that formally verifying it depends a lot on the application again, but formally verifying a contract is going to be slightly more expensive than just doing testing. Of course, you need the right people, you need the right tools, but I think we're really in a good place here. And even when you try to justify this to your boss, to the business people, now it's much clearer. Like verifying, I don't know, a controller for a sensor in an airplane that might crash at some point in some condition, that it might cause a cost for the company. It's really complicated. It's hard. There is a sort of a risk assessment in the middle, and typically it's not really worth it. They will judge that it's not worth it, most companies. In this case, it's pretty straightforward to explain. You have one contract, it has a bunch of money inside. If there is a bug, the money either are stolen or they get locked. It's really straightforward. So I think it's a very good place it's a place where formal verification really shines. All right. So what is Sapling, finally, halfway through the talk? So Sapling is, like I said, it's a protocol. And the first thing that we're going to do is we're going to need a new set of keys that are slightly different from what you expect. We have what we call a spanning key that is similar to the secret key that you used to have in Tezos, for example. And then we have a viewing key. Because transactions, like we said, are private, and not everybody can see your transaction, the data of your transaction on the network. There is a viewing key that allows you, who performs the transaction, to see the data inside. So you can see the incoming transaction, how much you got paid, and the outgoing, how much you're paying somebody else. And then you can generate what we call diversified addresses. So you can generate a bunch of addresses that are unlinkable one to the other that you can send to people to get paid. Then there is a different set of tokens that we can call shielded that live in what we call a shielded pool. So it's just a different, separate world. And the pool allows you to do the usual three operations that you would expect. So you can create tokens, you can mint them, you can burn them, or you can just move them. You can just transfer them from one user to the other. And the nice thing that we have is that when we move them inside the pool, we have that the sender and the receiver and the amounts are not visible to everybody, but just for the people that have the corresponding viewing keys. So this is a very good and strong privacy property. So just to try to show it in an animation, you can imagine that the gray ellipses is the shielded pool, and we can have shielded transaction inside of it. And then typically you have the problem of how do we bridge this with a more standard and transparent blockchain. And this is a typical problem that they had in Zcash at the beginning. The Zcash is a fork of a Bitcoin code base. So how do they bridge the two worlds? So imagine that this is the transparent world. Everything in black is transparent, it's publicly visible. So again, we have the same kind of transactions visible to everybody in the transparent world. And what we do is we want to shield some money. So Alice can send some money to its own address in the shielded pool. And then she can perform as many shielded transactions as she wants. And then once she unshields the money, or somebody else does, for example, to send them to Bob, we'll see an unshielded transaction from an unknown Sapling address to a transparent address, Bob. So as you can see, getting in and out of the shielded pool is a black arrow, so it's very visible and it's transparent. It doesn't provide you privacy. Staying in the pool does. So this is, from a regulator point of view, this is a game changer. And in a sense, it's just actually is going back to what was the status before blockchains. So first of all, everything that is in the public is completely encrypted, so nobody can see what's going on. And then who has the viewing keys can access its own data. It's pretty straightforward. And if you think about it, for an exchange or for an asset manager, is basically getting back to the state that they have now. They have their own servers that they control, what they can see everything, and they control everything, and nobody else can see their servers. And this is more or less for them, it would be getting back to the same status. Therefore, on exchange, for example, they could control the viewing keys of all their users, so they know everything that their users are doing. But still, they will protect the privacy of their users with respect to the external world. Okay, so how is this used in Tezos more concretely? So there is a new Michelson instruction that's called verify update. That's basically is going to take the state of the shielded pool and then one transaction that the user is sending to the contract, and then it's going to do two things. It's going to either fail. That's why it's called verify. So it's going to verify that the transaction is okay. You're not trying to double spend. You're not trying to spend money that you don't have. You're not trying to do something fishy. And that's why I put the option. So you could just return none and just say, okay, this is bad. Or if it returns, if the verification passes, it's going to update the state. That's why verify update. And what's going to return is going to be the new state of the shielded pool and a balance. And the balance is it tells you how many shielded tokens were created or destroyed. So you can imagine that, for example, when we are moving inside, when we are staying inside the shielded pool, the balance will just be zero. So we don't know how much. There are just the same amount of shielded tokens were created and destroyed in the transaction. So what can we make with this? It's pretty straightforward to make a contract that manages tokens. So something that's a privacy-preserving version of an FA 1.2, or if you know Tezos, or the equivalent of an ERC20 if you're a more Ethereum person. So two simple example could be if there is a one-to-one conversions from the shielded world and the transparent world, we're basically building a sort of shielded Tez. Otherwise, you can build a more complex asset manager that is going to do use some data from an oracle or create another contract to decide how to price the token, and then it's going to do a complex price. The price could adapt over time in a complex way, etc. So just to give you an example of how it's used in Tezos. So imagine that this is Tezos, and again, we have our transparent transactions that are in black and everybody can see them. In Tezos, the big difference with Zcash is that we have smart contracts. So we can have a smart contract that's going to have a balance, in this case 50. And now with Sapling, we have that a smart contract can also contain and manage a shielded pool. So the smart contract will be the gatekeeper of the shielded pool. So it's going to control the little black arrows going in and out. So for example, for the case of the shielded Tez, you can see that the smart contract also see the balance of the shielded pool. So the smart contract can check that we still have the same amount of Tez inside and outside. That is a property very important if you're trying to do a shielded Tez. And it's going to make sure that this conversion is kept. It's going to, if you send this contract 10 Tez, it's going to mint 10 Tez for you in the shielded pool. And if you try to withdraw 10 shielded Tez, it's going to burn them and then send you 10 Tez. If we're trying to do something more complex, like I said, we could have, for example, in this case, we see that the tokens, there is a balance of 10 inside the shielded pool. So we could imagine that maybe these tokens are worth 5 Tez each. And we can also have more complex rules for accessing the contracts. For example, we could have a whitelist and only Alice and Bob have the right to interact with the contract. And there, I mean, you just have the normal smart contract. You have your Michelson, your imagination is the limit. All right. So, what are the open questions that we still have? Open problems, let's say. There is the slight problem that in order to make the a smart contract run, you need to pay the fees for the gas. So that's pretty straightforward. The problem is that to pay that, you will need to use a transparent address, which means that everybody will see everybody. So even if you're sending a shielded transaction and you would like to keep your privacy, if you're still using your own transparent address, then everybody can see that your address is actually using the pool. So one workaround for this is to have a proxy injection service. So somebody else is going to have I don't know, a website where you can send your shielded transaction, and they will send them to the blockchain for you on your behalf, and they will pay the fees for you. Of course, you will put in your Sapling transaction, you will put a fee for the service, but that's a shielded fee. So nobody will see that there is where the fee is coming from or who's going towards. And the server is going to be able to reclaim his shielded Tez from the blockchain. Another problem, I would say, and this is really a question of design and how we. Yes, Adrian is right. That could be another solution. So how? So okay, another problem of, let's say, design and habits of operating these systems is the fact that every time you have a different contract with a different Sapling shielded pool, basically that's your anonymity set. So if, for example, the community decides that it's very useful to have a shielded Tez, then there should not be 50,000 contracts doing the same thing. There should be one single shielded Tez contract that everybody uses, so that everybody will enjoy the same large anonymity set. But this is really a matter of it depends a lot on the application. So if, for example, your contract is going to manage a lot of tokens, then it's a very good idea to use the multi-asset shielded pool that they're working on at Cryptium, because of course your token will be mixed with other tokens and with other users, and you will enjoy much more a much larger anonymity set. And then the last open question is about delegation. So again, if we want a contract to contain a lot of tokens and a lot of users, because in this way we enjoy better privacy, then some people might ask, wait a second, if I'm locking a lot of my tokens inside the contract, then it means that I cannot delegate them, and so this might discourage people. And one option would be to design contracts that can delegate, and that they will redistribute the rewards from their delegation to the people that are using the shielded pool. This is a complex question. There are a few designs out there, and I think I'm optimistic that we can solve this in a reasonable way. So what are the few things that I think are interesting privacy-wise for the future? Sorry, this is going to be proposed soon. It's going to be part of 007. Like Hadrian said, we hope that this month or next month we'll manage to propose this. So the next thing that we're really working on immediately is the private set membership. This is something that I'm quite excited about. Remember the example I was saying before, where you want to have a sort of access control where you can say that only Alice and Bob can use the contract. So in that case, I was talking about transparent addresses. So you will have Alice and Bob are actually some TZ1 address. So what if I don't want to show that to everybody who is able to access the contract? What I would like to have is have a set of users that I allow, and the list is not publicly visible, and you can prove, or maybe it is. Maybe the list could be visible, but the moment you authenticate to the contract, you send who you are. You prove that you're in that list, but that's a zero knowledge proof, so nobody can see who you are in the list. That's a very interesting property to me, and is linked to more work on identity that we hope to explore in the next months. And then the other thing that we'll be working for sure is enabling wallets. So the Tezos client already has very good support for what we built. Not everybody uses the Tezos client, and with people we want to use their favorite wallet or web wallet, mobile wallet. So there is a little bit of engineering to be done to make sure that we can enable all these wallets to interact with the Sapling-enabled smart contract. And then again, the multi-asset pool is a very interesting thing for the future. I'm done, so we can go to the questions. Thanks for listening. Waiting for Oliver to come back.
All right. Cool. Thank you very much, Marco, for this presentation. Sapling side of things is interesting.